So for B1, let's find the energy of a single photon. So you know E equals HF, which easier to go HC all over lambda, which is going to be 1240 all over 250. Again, you get to leave it in nanometers because this is electron volt nanometers. God, I love that. And having already done the mathematics, that comes out to be 4.96 electron volts. 4.96 electron volts. That's the energy of a single photon of this ultraviolet light. All right. Now notice that 4.96 is greater than 4.08. The fact that it's greater, that extra, whatever that is, about 0.9 of electron volt-ish, that's what's going to give us the kinetic energy that's going to get those electrons across and give us a current. Okay? So to do this next part, find the maximum kinetic energy of a photoelectron. Well, it's how much greater that is than that. That's your equation. Ke max, which does sound like a shampoo title name. Ooh, I need some Ke max. That's going to be, what did I say? It's going to be the energy of the photon, which is HF. We just figured that out to be that, minus phi. So 4.96 minus 4.08. Phi phi pho fum. And that comes out to be 0.88 electron volts. 0.88 electron volts. Way cool. The last thing is to find the stopping potential. What's the stopping potential? The stopping potential is where you can stop the current, and that's where you apply a negative voltage. So the potential difference is you reverse the battery, and you have a negative plate at the collector, which is repelling the electrons. And you crank it up all the way to the point where it just stops the current, and it just repels those photoelectrons that have the greatest kinetic energy, the maximum kinetic energy. If you express that as a repulsive energy, as a potential difference, a potential energy, then that would be E delta Vs. Remember, Q delta V is an energy. That's the energy of those plates repelling from collector to emitter. And that's repelling the maximum kinetic energy. So it's repelling those photoelectrons that have the greatest energy of all, and those are the ones with 0.88 electron volts. Remember, you have ones that have less energy than that. That's the maximum. Now, that's going to be E delta V equals 0.88 electron volts. As long as you're in electron volts, I just love the way this works out. That E right here, which is actually 1.6 times 10 negative 19 times this, is equal to that E right here, which is actually in the units, but they actually can cancel out. How cool is that? So what's the stopping potential? Well, delta Vs equals 0.88 volts. Okay? Once you know the maximum kinetic energy of the photoelectrons, you've got the same number. It's just that it's in volts. If you miss this question on a test, you're going to, do that. You can't even see my foot, but I'm kicking myself in the derriere. You don't want to miss that question. It's the same number. You just cross out the E's. Comes out to be 0.88 volts. How cool is that? All right, we're done. Yay, 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 yay. Bye.